Hi, my name is Pablo Magaz, and for today we are going to talk about the Deno APIs and how we can create a REST API using Oak, which is one of the most popular frameworks for API creation in the Deno ecosystem nowadays. Okay, let's get started. First of all, for the people who are not familiar with Deno, let's do a brief introduction. Deno is a secure runtime for TypeScript that uses V8, which is the Google's JavaScript engine, and is built in Rust. You're probably thinking that sounds pretty similar to NodeJs, and you are right. NodeJs was created more than a decade ago, and it was created by Ryan Dahl. And I think everybody would agree that it was a very revolutionary technology, JavaScript in the server, synchrony, event-driven, and a very, very, very good performance. But even though we are not here to talk about Node.js, it's going to be difficult not to talk about it because Deno was also created by Ryan Dahl, and it was created to solve some of the issues of Node.js. Let's take a look to the Deno's main features. First of all, Deno is written in Rust, which is an ultra-fast and ultra-secure low-level programming language that was created by Mozilla. Deno uses libraries like Tokyo for its asynchronous programming and for its event loop that works in a very similar way like the Node.js event loop. TypeScript is the default language in Deno. We can also use, for sure, plain JavaScript, but TypeScript is the default language and is supported out of the box. So we don't have to install anything. We don't have to configure anything, which is great, right? Probably one of the major issues with Node.js was always the security. And everybody remembers the famous case, like, for example, the cross-send malware with write permissions that was published to the NPM. Cases like that are not possible in Deno. But why? Because in Deno, every program that required access to the network, to the file system, or even to the environment variables needs an explicit permission to access to them. Node.js module system was a great progress a decade ago. Require was a wonderful solution, but probably nowadays is not so useful because the native and the standard ECMAScript module system is a better solution nowadays, right? Deno embraces the standard ECMAScript module system, and there is a very good reason for that, because Deno wants to be 100% browser compatible. And obviously, a proprietary module system wouldn't help, right? When it comes to the package manager in Deno, we have something very similar to NPM, but with some slightly difference. First of all, the package manager or the package repository in Deno is completely decentralized. It's not a centralized repository. And the dependencies are handled in a slightly different way, like in Node.js. For example, in Deno, we are not going to have any kind of package JSON. Dependencies are handled in a slightly different way, as we are going to see during the talk. Okay, those would be the most important features of Deno. And I think a good number of libraries and frameworks are key for the success of a technology, right? And if we have to choose a library or a framework to write a REST API or write a web application in Node.js, probably we would choose Express or Koa, which is a more modern one. But by the way, was also created by the same team. But in the Deno ecosystem, we don't have Express or we don't have Koa, at least officially, because there are some unofficial ports, but we have Oak, which is the framework that we are going to use for create our REST API. If you are familiar with Koa, probably you have noticed that the Koa and Oak, they have exactly the same characters in their names. Yeah, and it's not a casualty. And this is because Oak is highly influenced by Koa and its middleware system. In fact, we can consider Oak as a middleware framework that is built over Deno's HTTP server. And like Node.js, Deno has a standard library which includes an HTTP server. Oak is going to extend the functionality of this server, adding features like, for example, the middleware layer. One of the greatest things about Oak is its simplicity. It's really easy to use. It's very productive. And this is everything. This is because in Oak, everything revolves about three basic concepts. And the first one is the application. Application is a very simple class that is just a wrapper around the Deno's HTTP server. And it has just two methods. The first method is the listen method that will launch the Deno's HTTP server. For the people who is not familiar with top-level await, as we can see in the example, we can call the listen method using await, but without wrapping it in an async function. And this is because we are using top-level await, and top-level await is supported in TypeScript since TypeScript 3.6 or 3.7, can't remember exactly. The other method in the application class is the use method, and is key for which is probably the most important key in Oak, the middleware. If we say that Oak is a middleware framework, it's because middleware plays a very important role in Oak. And the middleware in Oak is a stack of async functions that will be executed in every request. Creating a middleware in Oak is really simple, and the only thing that we have to do is to pass an async function to the use method of our application, as we can see on the example. We are passing a very simple function that will display the classic hello world on the console in every request. But obviously, something that we want to do is to answer to the request, right? And we can do it. We can do it through the context. Context is a very big object that contains the request and all the parameters around the request, like, for example, the body, the headers, the URL params, but it also contains the response. And answering a request in Oak is something as simple as adding some data to the body property of the response, as we can see on the example, and Oak will automatically return that data to the request. Through the response, we can modify not only the data of the body property of the response, but we can also modify the response code. We can also modify the headers and much more stuff, as we will see during the talk. If we want to create an API, and no matter what kind of API, if it's a REST API or GraphQL API, there is something that we are going to need for sure, and obviously it's a router. In Oak, like in Koa, Express, or any other framework, we have a router that allows us to map our routes with a specific HTTP method using a method with the name of the method that we want to implement: get, post, delete, patch, etc. In this example, we are mapping our route API/hello world with the get method in the same way that we usually define routes in most of the frameworks or most of the routers, no matter if we are talking about routers on the backend or even on the front end. Okay, so those are more or less the basic concepts around Oak. We have the application, we have the context, which is the very big object that we are going to use to get access to the request and answer to the request through the response. We have the middleware, and we have the router, which is in fact a middleware. So let's get started with the creation of our users CRUD REST API. Since we are going to implement the users CRUD REST API, we are going to have a get endpoint for get the user data, a post endpoint for user creation, a patch endpoint for update the user, and a delete endpoint for user removal. In a real application, we will need a real database connection for sure, but for a matter of time, we're going to mock the database connection. First of all, let's take a look to the project structure, because all the examples we have seen so far were pretty simple, right? And if we want to create a good architecture that scales, we need to split the logic into smaller pieces and implement a separation of concerns. The idea of this distribution is to have our entities, like, for example, users, in this case, divided into small pieces. Obviously, we are going to have a server, which is going to be located in the main directory. The routes definitions for our entities, like users, will be located in the routes folder. But instead of implementing all the logic for the route directly in the implementation, what we are going to do is to split the logic into a separated file that will be located in the handlers folder. We can call them handlers, controllers, but it's almost the same concept. Every entity we will have its own database query executor that will be located in the DB folder. And as you can imagine, in the middleware folder, we are going to store our custom middleware, because we are going to write a custom middleware, very simple, but we are going to have our custom middleware. Since Deno uses TypeScript as the default language, we need some type definitions, and the types folder is the right place to put them. Speaking about the types, let's take a look to the model we are going to use. If we want to create a REST API for users, in that case, we need a user model, right? And as we can see, the model is pretty simple. It's just a neat interface with 3 very basic fields. First of all, we have the UI, which is the user unique identifier. Okay, we have the name, which is a string, and we have the birth date, which is a date object. Pretty simple, right? Well, we have also a type alias for the UI, but this is basically an string. Let's take a look to the route definition. As we were talking, it's a good idea to split the concepts and have the route definition in one place and the route implementation in another, because the route implementation could be very big, especially when we have to deal with several database queries, or even when we have to implement authentication, right? So in this file, we only have the route definition with all the methods we need for our API. For a user CRUD API, obviously, we need a post, we need a get, a delete, and a patch, because we want to get the user data, create a new user, delete a user, and update a user. As you can see on the example for methods like get, in that we need to access URL params, we define a URL param using a colon followed by the name of the URL param that we want to define, in that case, user ID. Apart from that, as we can see on the second line, we are importing all the route handlers method. We are using find user for the get method, create user for the post method, update user for the patch, and delete user for delete. If we take a look to the find user route handler, as we can see in here, we have a very basic async function that receives the context, which is the object that allows us to access the request and send a response. Since we are implementing the find user handler for the get method, we know that we need access to the URL params, right? In order to access to the URL or the query string params, Oak has a set of helpers like getQuery that will return an object with all the URL params or query string params that we have, and is going to return an object. As we can see, we are taking user ID, which is the URL pattern we defined previously on the route definitions. Okay, now we have all, everything that we need to call the database and get the user data, right? As we can see in the example, we are using a try catch. In the try block, what we are doing is call the database, call the method find user by ID, passing the user ID that we get from the URL pattern. We are looking for the user in the database, and if we find the user, we are returning the user object and attaching to the body property of the response. And as we saw at the beginning, Oak will automatically return that data as a response. If something happened because the user is not in the database, we are going to capture with the catch block, and we want to send a different status code. For sure, if the user is not in the database, we are not going to return a 200 status code, right? We are going to return a 404, and we can add that status code to the status property on the response. If we want to add some custom error message, we can do it attaching the error capture on the catch and attaching it to the body property of the response. The create user handler is pretty similar to the find user one. The purpose here is not to find the user in the database, it's just to create the user in the database, right? And since we have a post endpoint, the way that we have to access the data from the request is going to be a little bit different. Now, instead of get the URL data, we need to access to the body value, since the post data is going to be sent as a JSON object into the body, right? Oak provides an asynchronous method called body that returns the body value of the request. We can pass the params that we get from the body, in that case the name and the birth date, to our database query executor, in that case create a user. As we saw in the previous case, we are wrapping everything with a try catch. And in the case of we cannot create the user, what we are going to do is to send a 500 error using the status property of the response. If we take a look to the database query executor, which in this case is mock, is pretty basic. It's just an async function that returns a promise with the auto-generated UI, just for mocking purpose. But the idea here is, as I said, to have this separation of concerns. And since we are using a promise in here, I'm pretty sure that we can use this way in any kind of databases, no matter if we are going to use MongoDB, Oracle, MySQL, or any other kind of database. Okay, at the beginning of the talk, we were saying that Oak is a middleware framework. And one of the features of Oak is the ability to write your own middleware. And to write your own middleware in Oak is really simple. Let's think in the most basic example, the classic logger. What we want to do is to display the URL of every request on the console. We want to display as well the HTTP method. And in the case of there are some params on the request, we want to display those params, taking them from the body. Very simple, right? It's the classic logger. The purpose in here is as I said, is to display all the requests in the console. Probably you have noticed that we have a next method as a second argument of our middleware. And if you are familiar with Express, probably sounds pretty similar and familiar to you. And you are right, because the next method, the purpose of the next method is to pass the control to the next middleware on the stack. But the only difference here is that in Oak, the next method is asynchronous. Okay, so we have our routes. We have the route handlers to answer to the routes. We have the database connection. We have our little custom middleware to display all the requests on the console. And I think we have almost everything but the server, because obviously we need a server to connect everything. And first of all, as we saw at the beginning of the talk, we need an instance of an application because it's going to be our application server. Since the middleware plays an important role in Oak, we can add a lot of middleware, or at least the middleware that we need. In our case, what we need is to add our custom logger, and we are using the use method of our application to add first term the logger, and after we are using the use method to add the routes we defined in our route definition. Then the only thing that we need to do is to launch the server, and our REST API will be ready to receive requests. Okay, so that was everything. I think everybody agrees that create a REST API with Oak is pretty simple. It's a really easy to use framework, and it's very, very productive, right? Hope you enjoyed the talk. You can download the slides and the code we have seen in the talk using the links that you are seeing on the screen. Thanks for watching. Hope to see you soon. Thank you.